So a couple of days ago, I was thinking to myself, rather optimistically, I might hit 100 subscribers this weekend. And I was really excited. Yeah, about that. Andy, you magnificent bastard. Welcome, everyone. Let's get back to building a battery. So since the last video, I have picked up a few more supplies. I got proper heavier gauge wire cutters, got a couple of, I think they're 175, 150 amp DC bus bars, a matching roll of black grounding cable. This is the 4 gauge Anchor marine wire. I should like to mention a couple of the comments, which is really cool, thank you for commenting, were saying about being careful with oils and whatnot on these. That is normally a very, very important thing. The wires I'm choosing are specifically designed for boats where there's going to be a lot of crap, especially down in the bilge, oils, greases, and whatnot. These have a vinyl sheath that is designed to not go bad in those kind of harsh environments. They're designed to handle the grease, handle the oil, handle UV. They're generally really good wire, and you can tell by their cost. A lot of people, when they're building these batteries, use welding wire. If you're not in a marine environment, I'm sure it's great. If you're going into a marine environment, no. The tin plating on the copper strands in these wires goes a long way towards preventing corrosion. I don't think I've mentioned it, but all of the ring terminals that I buy are also tin-plated copper. Again, to try to minimize corrosion out on the water. A couple other good comments. One that came up a few times was asking if I'm going to put any separator between the batteries. The thought had crossed my mind, but I never put too much thought into it. But those questions prompted me to think about it, and I think I will. The principal reason being that even if I compress the batteries, which is a whole topic on its own and something I'm leaning towards, if for no other reason than to minimize motion as the boat's jostling and rocking on the water. The idea behind having an insulation layer between each of the cells is so that if the batteries kind of shift around a little bit over the years, you don't have the insulation of one battery wearing against the insulation of another battery. You get a little extra layer. I like that. It's not going to add a lot of thickness and it's not going to add a lot of cost. So that will be happening. So another thing I got was 3-stranded 12 gauge water-resistant wire for the AC side and a grounded 15 amp plug, which I'm going to use to connect the shore power of the Victron. If I make any comment or statement on this channel and it's wrong, please correct me. One of my biggest stated goals of this channel is to encourage newbies. I'm a newbie. I would love for the comment section to defy the YouTube norm and be a place where people are encouraging and educating. And I want to, as best as I can, lead by example. If I make a mistake, call me on it. I will appreciate it. If you think I might already know something, but you aren't sure, I would rather hear something I knew than not hear something that could have saved me. So please, post and share your knowledge, your experience. It really, I love that. So one of the ideas behind why I added the bus bars now, originally when I got the Victron out and I was ready to assemble it, I was thinking I would just hardwire everything and then come back and add the bus bars later. Why rush? Why not try as best as possible to do things the right way? I know I'm going to need the bus bars for connecting the solar chargers, something I've not yet talked much on the channel. I've got a couple of 330 watt monocrystalline solar cells on my roof. They're not run down from the roof yet. The conduit and stuff's there, but I haven't actually run the wire because I've been learning the battery itself. When those get brought down, they're going to be tied into the ground and positive bus rails. So that's it. Just decided to do it now. The other thing that stopped me last time was ring terminals. I went on a bit of a shopping spree and got a bunch more ring terminals. These are on top of what I already had. Hopefully I don't have to end a video again because I'm missing a ring terminal. I mean, now that I've said that, it's going to happen because I've got custody of Murphy on the weekends. Okay, I've been talking a lot I don't want to bore all of you lovely, lovely new subscribers. So let's get back to building. Okay, let's get started with the AC wire. All right. There we go. So if you recall with the switch, I mentioned how the green was the ground. There's the gold, that's the hot, the black wire. And there's the silver, which is the neutral. And this here, I don't know if you can, actually better not to put anything behind it. There's like a gland in it. Let's see if the gland will open up enough to accept this wire. Yep. Almost like they knew what they were doing. One thing I would also like to mention that came out of the comments, I had a few people concerned that as I showed things that either were wrong or were deemed to be wrong, I say that because I'm still learning and I don't know everything, they were saying, don't do it this way. People will come along and watch your video and think it's right. Let me please restate, I am learning. Nothing about this channel should be taken as truth. I am learning, I will do my best, and I will get things wrong. Getting things wrong is okay. That's part of the learning process. That's a really pretty shade of green. So these have, you can see them, little metal U-shaped thingies that squeezes the wire. I think I just need to push it down the side and clamp it down. Let's see how these fit in. We do ground first because it's the one of least consequence. Ha! Electricians just got angry at me. Ground is very important. I say least consequence because under normal operation, it should not be carrying the return path for the electricity. Hello, Lynx. I'm trying to get the copper in deep enough. There you go. You can see that. I wanted to get the copper in deep enough that the insulation of the wire is flush to that little U-shape holder. I can see a little bit of bare copper, but that's okay. There we go. There's the neutral. So you can see what I've done is the insulation of each wire ends just before it goes into that metal U-shape housing. That way, if the insulation had gone into that little U-shape housing, when I clamped it down, it would be squeezing on the insulation and not necessarily on the wire, or at least not as hard. Now, did I leave too much exposed wire here that might be about to pop out here? Oh, that would be annoying. How close can I get it? I think I'm going to have to do it again. Yeah. See, the problem is to pull it to the point where that sits, you can see how much is exposed here, which means that the gasket inside, the grommet inside, is not forming a seal. So I'm going to have to do this again. Slow and steady. Slow and steady. Slow and steady. Okay. Give everything another little unga-dunga down. Make sure she's good and tight. I'm being extra careful with the lead here because this inverter can easily draw the full 15 amps. So that means I have an ability, or the Victron has an ability, to pull up to 15 amps at 120 volts AC. Oh, would you look at that? Even after making it that short, it still pops out the back. How am I supposed to do this and keep the wire in the gland? Can I fold these? Okay, so what I'm trying now is I basically squashed all of the wires to try to keep this insulation as high up in the barrel of the connection as I can. And there, they've all bottomed out. And I don't know if you can see, but the gland is still around the outer housing. Now, you might think, oh, but Madi, the first time you pull it out of the wall, it's just going to pop out. Not so. It has an integrated strain relief. So this here will clamp down on the outer housing. Oops. So there's the other half of the strain relief. And what this will do is it here bites onto the housing. So when you go to pull this out of the wall in the future, the pull force is transferred to the barrel through this biting into the wire. So when you pull, it ends up pulling on the outer housing and the terminals rather than pulling on those screw joints inside. You might be wondering why I am bothering with ring terminals on a cable that I said is not permanent. The reason for that is more to protect the Victron terminals. I don't want to be just wrapping the wire around the Victron terminals and crushing the bolts down and mangling the threads and stuff. So the ring terminals are there to make sure that I have a clean connection between the wire and the Victron. The Victron was not the cheapest purchase, that's to be sure. To paraphrase a good friend of mine who I was talking to about this stuff before I chose it, Victron will cost ya, but it'll outlast ya. Hey, Damien. Someone in the comments had a really good point about putting the wire into the ring terminals. Their comment was, don't twist it and twist it and twist it. And the logic, which seems quite rational to me, is when the compressive forces are placed on the ring, or sorry, on the barrel, it's going to bite into all of those strands. And if you have two strands crossing over each other, as the bite pressure comes down, one might actually sever the other. So you want to leave them relatively in parallel with minimal crossing over. There we go. 3 ring terminals for the Victron. So that's the AC side done. What I'm doing here is trying to get an idea of where to put my bus bars. I'd like to keep the bus bars up high. So what I think I'll do is put the negative bus bar here and the positive bus bar here, meaning my battery lines have to reach there and there, which they do. So I went downstairs to get screws for the bus bars. I got slightly distracted by the fact that I needed a box for my breakers. This got me wondering, in the previous video where I went through the build of the stand for the Quattro, I wasn't really sure if that's something that would be of interest to the YouTube channel. Now, when I made that video, I had less than 100 subscribers. Now I've got about 1,000. So let me ask you, in the future, would you guys be interested, and girls and others, in things like the little woodworking projects where I make the boxes for these things? Or should I stay focused on the battery stuff, the Victron charger, that whatnot? With the breaker box made, I'm ready to mount the bus bars. All right, and for at least some sense of accomplishment, we're not going to plug this in, but we will get this connected. So we have our green ground wire bottom here. Our neutral is the white wire on the right, and our AC in 1 on the left. I'm a little concerned about how big that gap is. These ring terminals that I ordered are very broad, so there's maybe 3-4 millimeters gap there. So my current plan is, I see where I want to take a little bit of the metal off, so I'm just going to mark it with a Sharpie. And I'll do the same thing over here. I am not left-handed. That's okay. I'll know what to do when I have to get this downstairs. There we go. Trimmed back. It's not pretty, but it'll work. There. I think that's a reasonable gap considering we're only dealing with 120 volts and 15 amps at this stage. C'est très bien. When you're going to make a wire, you need to think about what ring terminals you're going to be using. So those are the ring terminals needed for the Victron. These are the ring terminals needed for the bus bar. So the Anderson connector will have a pair of these, and the jumper cables will have both sizes. I think I cut that too long. Oh yes, definitely too long. Verifying that I am putting the right terminal connector on. So this is the one for the bus bar, and that's the larger one for the Victron, and this is the jumper, so that's the right connector. I cannot tell you how many times I'm working with this insulator and I think to myself, this looks so much like licorice. Someone commented about bringing the heat shrink tubing further forward on the ring terminals. I don't see a harm in that, so I'm going to give it a try. I'm thinking I'm going to put positive at the bottom, only because if something falls and somehow gets between the plastic faceplate and the bus bars, I'd rather it bounce off the ground than bounce off the hot. All right, so I realized this morning when I was thinking about what I was going to do today, I don't have a neutral bus bar in here. So the breaker only breaks the hot side. So I'm gonna have to run the neutrals and the grounds just straight through here. That's not ideal, but this is just a project / learning box. So what I plan to do is use some butt splices to carry the neutral and the ground through, and the hots will go through here. So let's get started on that. Get that one to go there. It doesn't really matter, but I'd like to keep the cut part inside the box, so I'm going to do a little mark of where I want to split the insulation. You know, I have a proper knife literally at my feet. Run the copper and the neutral around that side for this run, and that run can go around the other side. This is going to be so ugly. I'll leave this long and almost certainly have to trim it back. There's a screw post at the top here. As you screw it, there's a plate that comes down and compresses the conductor that goes into the fuse. This is probably impossible to see. Why don't I pop the breaker out and show you? I'm hoping this is coming through. I can't really see through the viewfinder if this is going to come through. As I turn it, hopefully you can see the pad coming down, and that's what compresses the conductor. Oh! Ah! I'm glad I took this out. I was going to do this the wrong way. I turn it to lower it, then you put the conductor into the U, and then you turn it and it pulls the U up. Huh, I almost made a mistake. Would not be the first. Okay, so I've got to back both of these off. That would explain too why I was a little thrown off, because I'm turning anti-clockwise and it was tightening, but it wasn't tightening, it was just dropping the barrel down so that I could put the conductor in. Then I turn it clockwise to compress it. Oh, I love learning. Those little moments are what make it all worthwhile. Now, did I leave enough length on the neutral and the conductor, or the neutral and the ground, to form a connection? I guess we will see. Okay, so let's put this back in now. Okay, yeah, I can clip that a bit more. Okay, and just bumping up against the shielding. Okay, that looks better. Give it a tug test. Doesn't come out. Okay, doing this one first. The trick with lighting, I'm finding, is that it's easy to light a place up. The trick is doing so in a way that doesn't cast shadows super easily. Right now I've got the cheap studio lights I bought pointing right at me. I think what I need is, you see those big diffusers where it just kind of lights up the room? I think I need to get a couple of those. And now that I actually have more viewers, I won't feel so bad spending a bit of money buying some better studio stuff now. I'm still just absolutely shocked at how many of you have subscribed. I really, really, really thank you. It's just mind-blowing. Pull this out of the way. Okay. Yep, that looks like it's going to be long enough. Make sure the conductor is in the barrel. It is. I do plan to put a cover on this box once I've got it set up and working, to help prevent little kitty paws from slipping in here. I don't want kitties getting hurt. There's another challenge, getting the crimp tool in there. Slide it down the rail. Get these out of the way. I should have just enough room to get that crimp tool in there. Hopefully. That feels like a solid connection. If this was a metallic box, there would be screw mounts, and I would just take the grounds and just screw them around the mounts. But seeing as it's a wooden box, well, if your wood is conducting electricity, you've got very big problems. Okay. Balls. Well, that's why you do a pull test. To fail is human, to succeed is divine. Oh, cutting towards my thumb again. There we go. Take two. Okay, so let's get this in. There we go. One circuit done. Let's do the other circuit now. When I'm scoring this, I'm intentionally scoring it right down the center so that if the blade does nick a wire, it's nicking the ground, which has no insulation anyway, so no harm done. That one almost went in my coffee. Make sure it's in the barrel. It is. Got Tracy Chapman's Fast Car stuck in my head. It is absolutely not a problem. Ah, great song. Oh, need a bit more. All right, let's see if I ruined another one. Do we have a connection? Yes, we have a connection. Okay, cool. Okay, that's tight. That's tight. That's tight. That's tight. Those are tight. Those are tight. So, with that done, I'm still going to run through and do a continuity test. When I'm done, I should send this to my electrician and see how badly he cringes. So the problem I had on the feed lines I'm going to have with this one as well, and that's that the flat part of the ring terminal is so wide that the neutral and the hot end up being really close. It's not enough to short out or probably even arc, but it makes me nervous. So I am going to file these down the same way I filed down the other ones. So as I did with the last one, I put a little black mark where I want to cut off. 2 are going to be ground away in one direction, and 2 will be ground away in the other direction. I need something to clamp that better. Okay. And then just using a simple metal file. I don't even have a handle on it. Okay, that's good. Now, deburr it. Just feel it. If anything feels sharp, light hit with the file. Almost hit my toes. So you can see how much was taken off. The amount that's left is still wider than the bolt that's going to go on top of it. So it's not going to compromise the surface area for the conductivity to go through. And also keep in mind, these are for only 20 amps, which really isn't that much. AC amps. There, 4 modified ring terminals. And there we go. While I was filing back those ring terminals, I had a thunk. It hurt a little, but that's okay. I've got 2 AC outputs, and my whole purpose of this stage of the project is to learn the Quattro. So I'm going to run one to AC output 1 and the other one to AC output 2 from the Quattro. If I've got it right, AC output 1 will continue to provide power so long as there is batteries. AC out 2 shuts off when shore power is lost or generator is lost, but no generator in this case. I am going to print some labels to mark AC1, AC2, same thing on the breakers, and then we'll crimp these up and we'll get them mounted. Though, now that I've said that, that means, oh bollocks, the 2 neutrals have to have their other side filed off, because now I'm going to have a hot on either side. Yeah, and that grounding wire is definitely a smaller gauge. I could put both grounds together into the same lug, but I like the idea of being able to keep these 2 wires separate. That's a good pull test. Oh, look at that, look at that! That is not a good crimp. 1 moment, please, as Mr. Big Clive would say. Okay, that is ugly as sin, but it's gonna work. temporarily. It would absolutely not work for anything permanent. So anyway, what I did was I ran the wire off to one side of the ring, knowing that the split in the barrel of the ring was going to come apart, so that it folded in and tried to grab the wire, which is exactly what it did. As an experiment though, I am going to try to fold over the ground on the other side and see how that works. So if this works, what I did is I just folded it over and pressed it down. Oh, look at that, that still fits. Okay, cool. I think we're on to something here. Okay, that felt a lot more solid. Yep, I'm going to redo the other side. I'm sure it's pretty self-evident, but allow me to say, when you're ordering parts for a project that you're new to, always order more than you need. Because if you order more than you need, you might just get lucky and have almost enough. Much better. So let's say one, which goes through here, which goes through here, which makes this one AC1. And that will make this one AC2. I'm kind of struggling with the shadows. I hope it's not hurting how well you can see this. I usually film after work when it's dark out. And lighting is its own special skill. Arts and crafts with the digital mermaid. So one, that's one, okay. When I'm trying to place really small labels, I stick them on the end of a blade like my scissors. Can you see this? Once you've got it placed, just hold it with your finger and pop the blade off. That one's a little crooked, but oh well. It's good enough for now. Actually, that's going to bug me. I'm going to fix that. That's better. There you go. AC1, AC2. Let's do the same thing to the AC board. Put the label at the bottom so that I can see it if there's plugs. If I put it up here and I had plugs in, it'd be a little harder to see. Not that it really matters that much, but I like to think about little things like that. There. So there's the labels on the breakers. There's the label on the outlets. And I Sharpied the circuit numbers on the jackets of the main wires. Okay, so AC1 is on the left side of the, so if that's looking at the Victron, the AC1 is on the left, the AC2 is on the right. Knowing that, the neutrals are shared, so the neutrals are going to get the two ring terminals that I filed both sides off of. And circuit 1 is going to get the one that's shaved on the right. Circuit 2 will get the one shaved on the left. Now, if something I need to do is pay attention to the angle that I attach these ring terminals. If I put them so that the barrel is up on both sides, then what'll happen is, so they have to sit slightly crooked over one another, so the sides I shaved will be kind of pointing over. If I do them back to back, then I can keep the shaved off sides in parallel, so I maintain the maximum gap between the positives on either side. Now to validate. So the first thing I'm going to do is turn on the breakers. So right now they're off. So now the hot should go to hot, neutral should go to neutral, ground should go to ground. Hopefully you can hear that beep. You can see the multimeter. Not that the multimeter has much to show. Okay, so hot on AC1 to hot on AC1. Does this have a safety thingy in it? I might have to take the faceplates off. Right side is the pin. There we go. And if I pop the breaker, no connection. Okay, now neutral side, connection, and then chassis ground. Excellent. Okay, so let's do hot first. Connection, break it. Excellent. Okay, and the neutral. And the chassis ground. Ladies, gentlemen, and others, we are ready to set up our AC side. Connect our AC side. We've been setting up the AC side. There we go. Oh, it's getting busy in here. So remember how we did the back-to-back so we could keep them in line? This is where we now benefit from that. Now I'm reluctant to try to twist that ring terminal. Okay, so that's AC1. You know what, I am going to order the right ring terminals. It just does not feel skookum at all. Yep, I don't like these ring terminals. Okay, let's do another round of continuity checks to see if we've caused any shorts. So, check for ground. Nothing, nothing, nothing. Oh, actually tab. Yeah, it's working. Nothing, nothing. So ground is not shorted to anything. So in, there's that little beep we saw before, but I think it's just the capacitor. Nothing, nothing, nothing. Neutral, nothing, nothing, nothing. Line 1 to neutral. Why do I have a short on line 1 to neutral? What? What? So maybe that's normal for the Victron. Okay. No connection, no connection, no connection. Oh, AC out 1 is shorted to neutral in the Victron. What? Why would it do that? All right, well, the Victron has a short between line and neutral. Why? Wait, what? What? Okay, these are not plugged in. These are disconnected and dangling free, and I get a continuity between the positive and the negative terminals. Why? I have to assume that's by design? I am really confused. What's the resistance? Oh, this is interesting. Watch the resistance. When I first connect the probes, it starts off at like, right now it's showing 0 mega ohms, so it's an open circuit. But when I connect these two, and keep in mind, the battery's not plugged in right now, so these two wires are going nowhere, they're floating in the air. The resistance starts off really low, like 5 ohms, and then it starts to slowly creep up. I bet you there's a capacitor back there across those two. That would make sense. So if there's a capacitor back there, as the capacitor charges up, the resistance starts to climb. I think. And I bet you I'll see the same thing across these two terminals, because these two are protected by the battery. These two are not protected by the battery. So it would make sense if these are open and these have a capacitor across them. So let's see the same thing. Okay, so starting at 0, hope you can see that. Connect. 2 ohms, 3 ohms, 7 ohms, 1 ohm, 0.4. Okay, so now it's dropping off really fast. It's almost dead short. Ladies, gents, and others, I don't know what to do. This is incredibly expensive. I don't want to blow it, but I literally just pulled it out of the box. I mean, Victron is a very good brand. I'm sure they know what they're doing. What to do? What to do? What to do? Have lunch and ponder. That's what to do. So you can tell by the change of drink, it's been a few hours. But I think I finally figured out what's going on. Of course, with the help of my friends. Lord knows I ain't smart enough to figure this out myself. What I believe is happening, and again, when I say I believe, it's because I've had some people help me understand this. Outlet 1, AC out 1, is the one that is protected by the batteries. So it makes sense that the neutral and the positive are connected to the transformer coil on the inverter. So it makes sense that there is a dead short, or nearly a dead short, between these two pins. So what's happening when I touch the positive and negative post on the battery connectors? There's a capacitor behind there. And the reason we're seeing the resistance climb is because we're literally charging the capacitor off of the batteries in our multimeter. So that's fine. You expect a capacitor across those. If it doesn't make sense, it's because I'm still learning and I don't necessarily understand what my friend said. My friend, when he was explaining it, it made a lot of sense. It's one thing to be able to hear it. You don't actually understand it properly until you're able to explain it. So I understood what he was saying, but I'm not at a point where I can explain it yet. I'm sorry. Basically, this goes into, one wire comes out, wraps around the coil of the transformer, and eventually pops out the other side. That's fine. There won't be any power here until the other side of the transformer, the primary winding, gets power. When the primary winding gets power, it generates a magnetic field which will induce power on the output side. So this is totally fine. This is totally safe. I was having a thunk as well about these ring terminals. I don't like, yeah, see, I just twisted this a few times and now it's spinning on the wire. These are crap. I can't use them. So I am going to cut them all off and just strip the wire bare and do it like I'm doing an outlet, like a plug, where you just fold the wire over and screw the screw down on it. Ring terminals would have looked nicer, and I spent a lot of time figuring out how to shave these off. It's much better to walk away from work you did than to persist with work you did when it's not smart to do so. I really hope the lighting is okay. I'm trying my best to figure out how to do this lighting. Hell, I should probably apologize for apologizing all the time. I'm Canadian. It's what we do. When you're born in Canada, part of the grade school curriculum is learning how to always apologize for everything. I'm certain there are some electricians where, now that there's 1,100 of you guys watching, I'm sure there's some electricians who are going to be watching this and going, oh, Maddie, you sweet summer child, that's not how you do it. Seriously, you guys are just the best. I cannot believe there's 1,100 people subscribed right now. Like, holy crap. You're watching me learn. I knew that was going to happen. If you're going to be dumb, you better be tough. You know what? I'm leaving that in. I'm leaving that in. Because so many of you guys posted, rightly, apparently, you're going to hurt yourself. Well, you're right. Thankfully, I'm as tough as I am dumb. That looks better. Oh, that looks like a much better connection. Now, one thing I was wondering is, I thought this thing had a Bluetooth connection to it, but I don't know if it does. I know it has a VE Direct connection somewhere. I'm gonna have to figure that out. All right, that looks good. You know, one thing that made me really, really, really happy, like so happy that I wanted to mention it in this video, someone made a post saying, boat grounding is ... and they gave a wrong answer. And another commenter said, would it bother you if I told you that you were wrong? And the person who made the first post that was incorrect said, no, it wouldn't. Something to that effect. And I had to reply to those people and say, y'all are making me so damn happy. The biggest thing I want out of this YouTube channel, more than anything else, is to build a place, a community that is friendly for people who are starting out, where making a mistake is supported, not ridiculed. It is so easy to be scared to start something or scared to ask for help because you think people are going to laugh at you for being dumb. And, I mean, come on, nobody likes that. So when I saw the commenter post something incorrect and another commenter being kind with their correction and the humility of the person who was wrong to say thank you for correcting me, you guys are fucking legends. Sorry, I'm not going to cuss very often, but this is one time that deserves it. You guys are fucking legends. If I can do anything with this channel, let's make it the most supportive, friendly channel possible. All right, that certainly looks a lot more skookum, as a certain channel would say, than what I had before with the ring terminals. Let's try turning it on. Oh, no, I said I was going to read the manual. I spent all of that time trying to figure out why I was seeing the readings I was seeing. I'm going to pause the camera again and go reread the manual. We're so close. It's going to happen. It may blow up, but one way or another, this is going to fire up this video. Back in a minute. Reading the fine manual. So, as expected, most of the default settings are sane for running a single one of these. These can be paired to create a split phase 240 volt system, like you have in most North American residential setups, or you can get 3 of them and run 3-phase, which something I've been thinking of lately. This is a bit of a tangent. I've built my system planning for a 48 volt DC motor for the boat. One of the things that's been coming to my mind a lot lately, though, and I have a lot of research before I make any decisions, is if I got 3 of these, 2 of these batteries per banked into 3, I would be able to create 3-phase AC. I might be able to run an AC motor on the boat. I don't know if that'd be wise. To be determined later. I need to figure out where to plug this into, because this is how you program it. there's a set of dip switches up here that allow a certain amount of configuration of the system. So there's a GX user panel that you can get for these things. Mads has one on sale life, you can see on his. They're like really expensive, and I was thinking, I don't need that. I'll just do everything through my phone and USB, and eventually, hopefully, a future project I'm working on. But I'm starting to think, at least from a learning perspective, at this stage, it might be worth picking one up. Anyways, back to the point. The manual keeps referring to how you can use the VE Direct to configure this thing, but I haven't figured out where to plug this in yet. Funny thing, in IT, one of the things I learned early on is you never say, oh shit. You always say, huh, that's interesting. Doesn't scare the customer as much. The key thing I want to figure out before I plug this in, especially before I plug in the battery, is to limit my AC1 input to 14 or 15 amps. So if I can do that through the dip switch settings, then I won't be worried about plugging in, and I'm just going to plug it in because it's getting really late on a Sunday and I want to edit the video tonight. I think, though, I can control it through these dip switches. Dip. Dual inline pole? No. Dual dip. Chips and dip. AC in 1 can be set using dip switches DS8, DS7, and DS6. Default setting 60 amps. Way more than I can handle. So off, off, off sets it to 15 amps, 1.8 kVA at 120 volt. That's what I want. So you can see there's a little on symbol here. So when the dip switches are off to the left, it means it's on. The manual is showing AC in can be set to dip switches DS8, DS7, and DS6. So it's saying DS8, DS7, and DS6 have to all be off to limit it to 15 amps at 120 volts, which is exactly what I want. 8, 7, and 6 have to be off, off. Oh. Okay, so the manual said 6, 7, and 8. It said that the AC1 input should be limited to 60 amps by default, but looking at the manual, that would be DS6, 7, and 8. So DS6, 7, and 8 all being set to on. But here they're all set to off. Manual, did you lie to me? Okay, well, anyways, let's keep reading. So that looks right now to be set to 15 amp max, which is good. I'm not super worried if I screw this up, because if the Victron tries to draw too much power, it'll pop the breaker down in my panel on my house. AC in 2 can be set up in 2 ways using dip switches, DS5. Default setting 30 amp. So if DS5 here, which is currently set to off, off is 30 amps, on is 50 amps. So if this is set to off, AC input 2, which is the one on the far right there, is 30 amps. Yeah, that's more than I can provide right now, so I'm just glad I didn't connect that. There's a good thing. Don't use AC in 2 on anything that can't provide at least 30 amps. Okay, so in my case, all of these are off. That's what I want. So I'm going to consider the dip switches to be ready to go. What I need to figure out now is, looking at the lovely diagrams, where the hell is the VE Direct cable plugged in? Looking out there above the AC input and output, AC1 input and the 2 outputs are a couple of RJ45 connectors, which go up through here to connect to the logic board. What is that? Is that where the VE Direct cable can go in? Nope, that doesn't fit. Okay, so back to the original question. Where the hell is the VE Direct cable plug in? It says it's VE Direct configurable. Let me plug into you. I can't find it. I can't find it. I don't know where to connect the VE Direct cable. I'm feeling really, really stupid right now. These two here are for display, and then slave to the second if you're doing split phase. And then if this was the second, it would come in here and then out to the third one for 3-phase. So that's not the VE direct connector. Does it just come up as Bluetooth? Okay, you know what? Let's put this together because I'm feeling, hopefully I'm not going to regret these words, confident. I'm feeling confident. I dare say it. I keep saying it can be configured by a PC. I just don't know where to plug it in. Okay, charger only on off. Rocker panel is in off mode. If I'm about to royally screw this up, I want to make sure you get my face in it and you can see me cry. The last time I was this nervous was when I was about to connect the BMS balance leads for the first time and turn on the battery. When I plug this in, the Quattro should power up, but not try to charge the batteries. It should not provide any voltage out. So we will literally just be powering up the circuitry and booting this. Now, Andrew, if you're watching, I know you said don't connect this, leave it out. Forgive me, I have sinned. I'm gonna leave it connected, mainly because I just wanted to get the wires out of the way. Oh lordy, I'm nervous. Okay, let me open up the Victron app. Let's do this. It's plugged in. So far, that was very anticlimactic. Oh, I'm hearing a buzz. All right, let me check AC voltage. I should see, I don't know if you're going to be able to see this, but I should see 120 volts across this. Yep, 120 volts. It's alive. I should see nothing here because it's off. Nothing. Nothing. Switch to DC. I should see no potential here because it shouldn't be trying to charge. Nope, nothing. All right, let's do a refresh. No devices found. This might be a very anticlimactic end to this video. It's powered up, but I don't know how to talk to it. Oh, the process of learning is fun. I'm the Digital Mermaid. Next time we'll figure out how to actually talk to this thing. Bye.